A carat of alloy contains gold, copper, zinc, and silver at a rate of 9 to 12.5 to 2.5. Write the ratio in simplest form. Well, you never want to have a decimal as a ratio in simplest form. So what you're going to do is multiply all the numbers by 2. End up with 18 to 25 to 5. The next one, how much silver would you need if your alloy contains 6 grams of pure gold? And I already set this up where W is the whole, P is the part, G is gold, S is silver. That's a good way to keep the proportion organized. So the ratio of gold to silver is 18 to 5. So I just put that as whole. And then if you have 6 grams of pure gold, sorry. If you have 6 grams of pure gold, then how much silver are you going to have? With 1.7 grams approximately. Try to solve C on your own now. And there is your solution. Bob and Frank want to share $96 at a ratio of 3 to 13. How much does each person get? This time I'm going to use part and total, and if you look at this ratio, the total is 16. We have that part set up. It's easy. So Bob, let's find how much money that Bob gets. He's getting a 3 to 13 ratio with Frank. So we use 3 for Bob, 3 on the ratio side. We'll put the X on the money side, and then we just cross multiply and solve for. Wind up with $18.78. Angle has a perimeter of 120 centimeters. The ratio of its length to its breadth. Oh, hang on. Gone a little bit. I don't remember when I left off. Breadth means width. So indicate the length of the length. Indicate what the length and the breadth of the rectangle is. The entire perimeter, we just want half. We want one breadth and one length. So we're going to call it 60. So we're going to use 60 centimeters. Okay, the hole is 60, so we're going to use 60 here. I'm trying to draw this with my mouse. Okay, and the hole, if I add the ratio together, is 8. And I don't care, let's find the breadth first. So we're going to put the breadth, it's a 5 to 3 ratio. And this is what we're trying to find. We're trying to find the length of the breadth. So I'm going to put X there. And the breadth is 22.5 centimeters, the length is 37.5 centimeters. Looking at ratio scales, which are convenient if you're working with maps and you're trying to go from distance that's on a map to distance in real life. Let's look at the first one. Write 4 centimeters to 25 millimeters as a ratio scale. And you always want it to be in this format. So I'm going to rewrite this to be 25 to 40. And I'm going to divide both sides by 25. The solution is 1 to 1.6. Next one, we're going to write 25 to 4 in the form of n to 1. So all we do is divide both sides by 4. 6.25 to 1. The scale on a map is 1 to 50,000 centimeters. What is the real distance between 2 points if they are 10 centimeters apart? Okay, I'm going to set this up with map in real life. I made an error which I just fixed, but the map to real life is set up this way. Multiply and you get 500,000 centimeters. Now we have to express this distance as kilometers. Well, there are 100,000 centimeters in a kilometer, so the answer is going to be 5. There it is. Simple problems in this chapter as well. Just remember that rate is equal to distance over time. The plane is going 800 kilometers per hour. hours are going to cancel, and we're going to know how far the plane went. One's from your book. I took a picture of it with my phone, so I'm sorry if it's a little bit blurry. Actually in the 8th grade curriculum, so you've seen them before, I assume, but you'd be surprised. A lot of people have difficulty with them, and I'm just not sure the reason for it. So I'm going to walk you through this one. It says, clearly and concisely describe the taxi's journey. When it says it, if it says something like that in the IGCSE exam, you're going to want to describe what's actually happening. So the first, and as you can see, time is always on the x-axis because it's independent. Distance is dependent on time, obviously. So if the first 50 minutes, okay, you can follow this. The first 50 minutes, and here's my working for how fast the taxi was going. They expect you to know how to determine what the rate is of the taxi if you're looking at these travel graphs, and it's 12 kilometers per hour for the first 50 minutes for the first 10 kilometers. You know, you can put it in your own words, but you have to remember to keep all the details in here, regardless of how you word it. Okay, it was in stationary for 50 minutes. Let me get this pointer. Okay, so you could see for 50 minutes, it was stationary. In other words, it wasn't moving at all. Now we can follow this down to 100, and we were at 50 minutes. Okay, so it's stationary during this time. Okay, then it returns. It then drove back 10 kilometers at a speed of 20 kilometers per hour. It was then stationary for 40 minutes, which is here. So I think you're getting how this works, so I'm going to stop talking about this problem. What was the total distance traveled, which is part C? .25 kilometers is a solution for that. The average speed for the first 20 minutes takes to this point. So for 4A, you're going to get 12 kilometers per hour. So that's 4DI. And then for 4D4, which is this very last one, give them the Hafeng. I'm going to go over this because this is probably the trickiest one. To do the total distance over the total time, and you get 6.25 kilometers per hour. Okay, here's an acceleration graph. So as you can see, the first 2 minutes we're accelerating. The last 2 minutes we're decelerating. And they want us to draw a speed time graph of this journey. This is what it would look like, except hopefully it'll be a lot neater. Anyway, for the first 2 minutes, 60. For the last 2 minutes, it's decelerating. 60 was the fastest speed it went, so that's why 60 is the top of it, the apex. And for part B, as you can see, it went 2 kilometers in 4 minutes, converted to kilometers per hour, and you're finished.